Hi and welcome back to the Mr. Talbot Maths video, and this week's video is all about this problem here, another geometry problem, and we've got to work out the yellow area. Okay, so there's a few key things here that you might notice first of all, and that's that some of the side lengths are the same. But before I do that, the first thing I want to do is give you time to pause the video if you want to, so you can have a go at the problem yourself. The next thing I want to do, and maybe before you pause the video, label the vertices, because I know I get in the comments some people saying, "Oh, why don't you label the vertices? I can't, I don't know what you're referring to." So I've made sure I've labeled the vertices. So yeah, if you want to have a go at this problem now, pause the video and try and solve it yourself. Okay, right, I'm going to go through now my solution. So basically, the way I went about doing this, like with many problems, which is quite a good idea, is to work out everything you can work out first of all. So first thing was label these side lengths, the 4 and the 6, that the lines through the sides basically tell us are the same length, okay? The next thing that I wanted to do, like I say, is work out the things I can work out. So I decided to work out the area of this triangle ABC. Now, the area of that is half the base times the perpendicular height. So we need two perpendicular distances indicated by the right angle. 4 times 4 and half it gives us an area of 8. Now, when you get areas, I would highly recommend putting that on your diagram if you've got one. So I've put that on there, I've labelled that, so that will help me hopefully later on. Now the next thing that I noticed I could work out is the area of this right hand side trapezium, and to be more specific, ABDE. Okay, so the area of that trapezium. Now I wanted to work that out because I knew that that area included the yellow area that I want to get to at some point later on. And I've already got the 8, so then if I can work out the area of this like lower quadrilateral later on, CDEG, then I can subtract that as well as the 8 to leave me with the yellow area. Well, that was my thinking. So the working out the area of a trapezium, you add your parallel sides together. So that's going to be my 4 and my 6. Add them together, half it, and then you times by the distance between them, which in this case 4 add 6 is my 10. Now that gave me an answer of 50. So the area of this right hand trapezium, which I can't really draw on my diagram because it's made up of three separate shapes, or yeah, compound shapes, so it's a bit more difficult to draw that on there, but the area of that is 50. Now the next thing, this, you can go about this problem different ways, but this really made my solution what it is, and basically what that is I made it into a rectangle because I thought that might help me. And, like with all these problems, you try different things. I thought that might help me. So I made it into a rectangle with a right angle at the top left there, as you can see. And then I labelled that again H. So we've got that vertex to refer to later on. Now, what I then did is I worked out what those lengths must be. Well, the left-hand side and the top must both be 10, because you can see the base, 8 add 6 is 14, 10 add 4 is 14, and the right-hand side, 6 add 4 is 10, so the left-hand side of my rectangle must also be 10. Now, I've also put lines through the sides there because they're the same length. Now, this got me thinking, in that, could this shape that I need to work out, this bottom right green shape, CDEG, that quadrilateral, could that have some connection to this top left quadrilateral, okay, AGFH? Because they've both got side lengths that are equal, 6 and 10 respectively. So in order to prove that, I needed to find that the angles were the same. And if I can work out that the angles were the same, then they're similar shapes, and then I can use that to get a kind of scale factor, which will then, I basically would be able to work out, hopefully anyway, the areas for everything. So that was my next thought. So I found the area of the rectangle because that was relatively easy, and that might help me again later on. Well, I would need that if they were similar. Okay, so area of my rectangle was 140, your base times your perpendicular height. Now, then I thought about finding the area of this left trapezium. Now, again, my thought process with that was, I've got my right trapezium, I can work out my left trapezium pretty easy because I've got the area of the rectangle, and I could have just done 140 take away 50, that would have been a bit easier, but I decided to use my formula for the trapezium again. So, parallel sides, 8 add 10, and then you half that, because you're finding out the average kind of width of your parallel sides, and then you times by the distance between them. So essentially you're working out like the average rectangle, and then that would be, will have the same area as this trapezium. So I get the answer to that being 90, which of course we know it should be. 140 take 50 is 90. But then, like I say, I wanted to look at the angles to show that these definitely were similar. So I've got vertically opposite angles. So vertically opposite angles are opposite angles at a vertex like we've got here. They must be equal to each other. And then what I wanted to do is I wanted to try and work out, like I say, if some of these angles were the same. So I didn't really know any other way of doing this than calling one of the angles theta. So this bottom right angle here, actually, bottom left I should say, sorry, HFG, I called that theta. Now the reason I did that is because I know there's a right angle there, and then I can get an angle in this triangle CDF. So the angle CFD must be 90 minus theta, because it's a right angle. 90 degrees minus theta is 90 minus theta. And then I've got two angles in this triangle, CDF. I've got 90 degrees and I've got 90 minus theta. So if I do 180 minus 90, I get left with 90. And that tells me that the third angle, the angle at the point C, and the angle at F in this triangle must add up to 90. I've got 90 minus theta, so the final angle at C must be theta. So that's specifically that is angle FCD must be theta. Okay, so now I've got in these top left and bottom right quadrilaterals, okay, I've got angles of theta. I've got two right angles, a right angle in each, and I've got a vertically opposite angle which is the same. Now because three angles in the quadrilateral are the same, that means that the fourth angle here, which again I've labelled, must also be the same. And I decided to note that these are the same using a dot rather than going to three lines through the angle, but these are the same. Now that's important because now I've got what I need. I've got all four angles are the same, and so what that means is that these two shapes must be similar. Okay, they're unusual shapes. Okay, they're irregular shapes, but they are similar shapes. And so then what I wanted to do is I wanted to look at the scale factor, and specifically the first thing I can do is find the length scale factor. Now I'm talking about going from the smaller shape in this case to the bigger shape. Okay, what would I multiply by to get from the smaller bottom right quadrilateral to the bigger top left quadrilateral? And so the scale factor is going to be timesing by 10 over 6, because you divide my 6 by 6 to get 1, you times that by 10 then to get the 10. And that is going from either of those two sides. So 6 to 10 or 6 to 10. They're the only corresponding sides I've got. Now you can simplify that to make things a bit easier, and we get 5 over 3. And then the bit that I need is not the length scale factor, but the area scale factor. And so to get that, what we need to do is I need to square the length scale factor. Okay? If you need the area scale factor, you square the length scale factor. If you want the volume scale factor, you cube your length scale factor. You cannot just go from area to volume, but anyway, I digress. So the area scale factor, square the 5 is 25 and square the 3 is 9, so we get 25 over 9. Okay, now at this point, this is when I really start thinking about the fact that I can get these areas in terms of each other, and I've then got an area of this left trapezium, and I could also work out the area of this triangle CDF, and they will cross over, so they would both have so basically some amounts of the similar shapes in, because I've got the scale factor, and they both have the triangle GEF in it. So I decided to label these to make things easier. So that triangle GEF, just labelled A, that's going to be in both of those shapes, the trapezium and the triangle. And then I decided to label bottom right irregular shape B. And then using my scale factor, this must be 25 over 9B. Okay, because obviously it's bigger, so I'm going to multiply that B by my scale factor. Okay, now what that gave me, like I say, using that left trapezium and using the triangle CDF, I've got two equations. Now the first one is using the trapezium. So basically I've got 25 over 9b, that area, plus a, the area of that, must be equal to the area of the trapezium, which we said earlier was 90. Now the second equation I get here, and this is from doing a plus b for my triangle, and the area of my triangle must be a half of the base, which is 14, times by the height, which is 6. Now simplifying that a little bit, I get 42 equals a plus b. Now hopefully you can see at this point that we've got everything we need. You know, we just need to go through the steps. So I'm going to put these equations on the top right here. Now simultaneous equations, it's good practice to make sure we label these. And then what I'm going to do, because they've both got a's in them and they're both positive, I'm going to subtract the equations. So I'm going to do equation 1 subtract equation 2, so that I get a positive amount of b's, because 25 over 9 is obviously greater than 1. So I do equation 1 take away equation 2, and the other reason for that I suppose is 90 take away 42 is going to give me something positive, which is 48. 25 over 9b take away 1b is going to leave me with 16 over 9b. Divide both sides here by 16 over 9. So I'm going to do 48 divided by 16 over 9. That gives me that b is 27. And then we get that a by doing, well, we basically got with equation 2, a plus b is 42, 27 add something is 42, so a is 15. Now again, I've now got all my areas, so let's label them and tidy everything up like we've done there. Now the key part of the earlier working out, the bit that I knew that I wanted essentially from the start, was the area of the trapezium, this right hand trapezium, because I've got two green areas and I've got one yellow area in there to make the area of that trapezium. So the final bit of my working out is this area 50, take away my 27, take away my 8, and that gives me a final answer of 15 units squared, which is the yellow area. Okay, I hope you enjoyed that video. If you did, please like the video and please subscribe. I'm really grateful that we've been able to get up to as many subscribers as we have, you know, as quickly as we have, and I'm really grateful that people watch these videos. So yeah, if you did enjoy this video, please like, and if you haven't already, subscribe to the channel. Okay, thank you for watching, and I will see you next week for another video. Bye bye.